fun figuring out what would happen if you saved like this. So assume you're 22 years old when you graduate, right? So you can change to whatever age you want. And assume you're going to retire at 55, so you have 33 years, I'm sorry, to invest, right? And then you're going to die when you're 90. Sorry, you guys. Okay, but anyway, just picking a time. So actuaries can figure out when you're going to die if you're buying a whole life annuity, right? So anyway, what I would do is I would just leave my money invested, pull it up myself, right? If I earn less, oh well. If I earn more, it's nice. That's what I'm going to do. So I'm not going to buy any annuity. They want too much of my money. They'd rather keep it for me. But anyway, so you got 35 years until you die. Okay? You guys should be happy about that. That's a really long life. Okay. But, okay. Anyway, for the first 5 years, your salary is only $50,000 a year, we'll say, although it'd be going up, of course. So it's not totally realistic. 12% is what you're going to earn out in the market, which is what the market's earned the last 30, 40 years. 12 to 13%. Okay? Annualized return. So, but some of that is inflation, right? Okay? So, and we'll do something with that later when we're done with this thing. But anyway, so assume you're earning 12, and you're putting in 5,000 at the end of each year, okay? Which makes it what kind of an annuity?
Ordinary.
Ordinary. Due is at the beginning, ordinary is at the end. That's an ordinary annuity. Okay, so of course you can't earn it until you put it in, right? So it changes how much you earn. All right, so that's for 5 years. Then you got a 10-year annuity, 12% also at the end of each year, $10,000 each year. That's when your salary is 90, so we're gradually taking more of your salary, okay? Which makes sense. Third group of annuities, 10 years, 12%, 20,000 per year going in out of 150. And then the last 8 years, you're going to still earn 12%. And I could change these to different interest rates, of course. And might have a problem, you never know. So watch for that. 30,000, and that's when your salary is 180. Okay? Then at the end of the 35 years, I'd like to know how much you've got. Or 33 years, I'm sorry. I'd like to know how much you've got. Okay? So at the end of 33 years, okay, how much do you have when you're 55 years old? And then convert to an 8% rate for the last 35 years after you retire. We're going to get conservative for some reason. I am also not doing that because I just go away earnings. But anyway, but there's less risk. Less risk of losing your money, right? Okay. So obviously, the lower return you're willing to accept, typically there is less risk. Okay. You can put your money in your savings account at 0.5% if you want. You got to calculate that one on this, and it'll convince you don't do that. Right? Besides, inflation will be more than that. Right? So on savings accounts, you actually lose money with inflation. So anyway, how much you have at age 55, and then assuming you want equal annual payments at the beginning of each year, which makes it what kind of an annuity? Annuity due. That's it. Okay, so I got an ordinary annuity here, a bunch of ordinary annuities, and then an annuity due. Okay, what will be your annual annuity payments? Okay, how much are you going to be able to take out of it? Okay?
So for at 8%,
yeah, this one's going to be earning at 8%. After you know one, then you're going to invest it in an annuity that'll pay out over its life, earning 8%. It'll go to nothing, right, by the end. Okay? There'll be all kinds of calculations like this here for you guys as well. Okay? You got to do it for yourself. I've done it for myself. It's pretty distant. My wife likes cars. Instead of buying $30,000 cars, we bought $10,000 cars, driven around in little tiny things. We'd be rich now. Couldn't convince her. Really? I told her. I told my kids, too. They're not doing it either. I'm glad they're not making grandbabies for me instead. They retire rich. Okay, anyway, so. All right. So I'm still here. What the hell? Anyway, I could retire now if I didn't want to live very well. Right? So could you guys. You can retire right now if you don't want to live very well. Yeah, right. Probably not. But you could, actually, live really poorly. Anyway, so I have an answer. I gave exactly the same one that I used another semester. In fact, I found one. And so let's see if we get the same answer this time for a different one. Lots of times we get different answers. So anyway, have fun with this. Okay. Try and do it for next time, okay? And then for now, what I'd like you to do, you guys all know how to do present values and future values, don't you? You did it in principle. If you're with me, I did it with you. If you were with Jack, he did it with you. So I know you did. And then in accounting 102, you did it too. In 101, you did it, and 102 both. And you've done it in math classes. So here we go. I want you guys to work a few of them. This will hopefully be a review, but it's not really, because I bet you guys can't do them all. But these, I bet you can't. I hope you can at the beginning. Okay, present value is what $1, or what we have right now, right? It's what we have right now, present value. So let's say I have $120,000 right now, okay? I would like to know a future value some number of periods from now. That's what I want to know, okay? So here's my first one. This is number one. Okay? My interest rate is 10%. My number of periods is 12. Okay? All right, here's one. Do that. Number two. I'll make up 4 problems and you can do it, okay? Number two, I don't know what the answers are, I'm just making them up. Present value at time 0, I'd like you to calculate that, okay? Future value, some number of periods from now, obviously the number of periods here and the number of periods here have to be the same, right guys? Okay, so this is $200,000, so I'm going to get $200,000. Based on my risk level, the interest rate should be 15%. My number of periods equals 10. Let's change this just a little bit. Make this be 16%. But this is 10 years, and the interest is going to be semi-annual. It's a bond. Okay? And that's it. So actually, if you know any 3 of these 4 things, present value, future value, interest, and number of periods, you can calculate the other one, right? So let's keep going with that idea. And you're welcome to use your calculator, or you can use the tables in the book, right? You can do formulas, I don't care. If you're a math whiz, you might like that. Let's say the present value is $100,000. The future value times 0, that's now, okay? By the way, it doesn't have to be present value 0, it can be present value 4 years from now, okay? We can do that kind of thing, so that's why we always put 0 on it. 0 means now. Okay, let's say this is 200,000. I want to know the interest rate. Okay, 10. And it doesn't matter if it's 10 years or 10 months or whatever, it's 10. They're years, obviously. Well, maybe obviously. Okay. All right, and then I'm going to want to do another one. Everybody got that one down? Actually, you can still see it there probably. 4. Whoops, smaller. Okay, can you do those 4? Do that first. Then we'll switch to annuities. It should be really fast. If you have a calculator that does present values and future values and you don't know how to use it yet, get out online, find the instructions for your calculator, and figure out how to do it. If you have a scientific calculator from another class, math class or something, science class, it'll probably do it. It's finance functions, right? How many do not have a calculator that calculates present and future values and units and stuff? You don't have to. You can use the tables in the book. Okay, you don't have to get one. Right? No problem. Okay. In real life, we don't use a calculator either. We use Excel. Right? Because it's faster. You got a whole screen in front of you. All that. Okay. So it'll calculate it for you. You know what? You've heard this phrase in computers, right? Input garbage, output garbage. The fact that your calculator knows how to do it, does that mean you know how to do it? No. Right? You got to put in the right data to get the right answer out. Okay, so this is going to be hard, you guys. But you do have to know how to use the calculator, obviously, or it'll take you forever to do it by hand. Okay? But you use the tables. Tables work really good too. And we'll take a look at the tables. In fact, I like to look at the tables from a perspective of learning it, right? Sort of getting oriented. How many of you can guess what exponentials are? You know, what is 1.125 raised to the 43rd? Interest rate is 0.125, You know how much that grows to in that period of time? I don't have a clue, right? I need the calculator. The tables so you start visualizing it. The tables are kind of cool. Kind of for that. And the tables are on what page? 334. Thank you. 334. You want to use them. They're just fine. They just calculated it for you. Use the calculator. We calculate those four really fast. Please, just take any time at all. Just a little redo of the rest. This part.
Did you go back down to number 4?
Yeah, sure. I wrote it down and then immediately skipped. Really good planning on my part. Sorry. There you go. 3 and 4 are just alike, except in one case I want the interest, in the other case I want the number of periods. And I don't know that those two work out in any way whatsoever. Yeah. They're not really related to each other. Other than having the same number. And I don't know if they'll be on the tables or not, but if they're not on the tables, it's not a real big problem, because we can do something called interpolate. Get close. Get rough estimates. Does everybody have their quiz now? Okay. Why didn't you get you to set up somebody else? I think you were late. I know you're on. I was really funny enough. And if you guys are paying me this in or you're not, I really enjoy it, but still. Got our answers? Yes? Yeah. So everybody, you guys got some numbers? If you know how to use your calculator, this is really fast, huh? Even if you don't, it's pretty fast. Let's set this up. How would you think about it? And the main thing is, do you understand what you're doing? Like, what are we trying to get here? This is just what, the first one is just what 120 would grow to the compound interest, right guys? So what are we going to do? We're going to take the present value at time 0 times what? 1 plus the interest rate, right guys? Raised to the number of periods equals the future value that number of periods from now, right? Do you think this way yet? Need to. And I don't mean you need to think in mathematical notation, you need to think in terms of what's going on here. So I'm adding interest to the interest because obviously you want interest on your interest as time goes on, right? So what this is going to be 120,000 times 1.10. You want 1 is you want your money back, right? That's the 1, right? And then the interest, you want interest, true? So remember we did this in principles, right? We've done in other classes. So it'd be times 1.1 would give you what you have at the end of the first year, and then you would invest that, right guys? Okay? For the next year, you'd want the principal plus the interest to have 10% interest on it. So it'd be 1.1 times that. And you just keep going until you were done with 12 periods, huh? So it's times 1 plus the interest rate, 1 plus 10%, I guess, raised to the 12th, because it'd be 1.10 times 1.10 12 times, right guys? We just keep raising it, okay? So exponential growth. All right, so what is 1.10 raised to the 12th? You can use a calculator to do that if you want. You use the tables. I think we've got that on the table, don't we? What is that factor? We call that a future value of a sum factor. If I know the present and I'm trying to calculate the future, this will matter when you start doing annuities, okay? If I know the present and I want to know the future, I call it a future value of a sum factor. Does that make sense? It's growing, right? Okay? So, because I'm adding interest, that's all I'm doing. Okay, so what was the factor of 1.10 raised to the 12th? If you looked up in the table, you can find it, or just with your calculator, what do you get if you do that? 3.13843. 3.13843. What's worth $3.14? $1, right? Compounded at 10% interest for 12 periods. You will have 3.14 times your money. Got the idea? So what will the 120 grow to? At 10%, your money grows pretty good, right? Okay? Didn't double twice, though. Okay? 12% probably would have doubled twice. Yeah, 12%. Okay, pretty close. All right? What's the factor for 12%? Look at the factor at the table. 12%, 10 periods. What is that factor?
3.10585.
That's not right.
376.
10%, 12 periods was 3.1384. So what's 12% for 12 periods?
12 periods, 3.8.
I might have said 10.
3.895.
Okay, almost 4. You had to have almost 4 times your money, right? Double twice. Right? Yeah, okay. Anyway, so, but it's not $1 I have, it's 120. So 120 times 3.13843 is what it would grow to at the end. Everybody agree? It's just future value of the sum. Okay? So I got a present value of the sum, I'm calculating a future value of the sum. A little review here. How much is that?
376.
How many of you had that? Pretty much unanimous? You could do it. This is not a big deal, right? Just relax. I'll actually give you some of these. Okay? It's no big deal. So I'm adding the interest. Now, if I was going to do it, so that's the future value. Okay? If I was going, if you wanted to use the tables, where would you look, guys? Future value of the sum. So take a look at the future value of the dollar table on page 334. Do that even if you're using your calculator, it's a good idea. Take a look at this thing and you can see what the growth looks like on this. So then what would we do? Go over to the 10% column, guys. Go down to 12 periods, and what do you get? It's 3.13843. By the way, is that number accurate? You gave me exactly the same one, right? But there were more decimal places in yours.
Yeah,
I keep getting them out. You just rounded it. Which is more accurate, that calculator or this table? Calculator. So is a computer. So would you ever use tables in real life? Of course not. What if they give you a factor on a CPA exam? I don't use it. I don't care. What if they give me a table on a CPA exam? I don't care. Right? I'm not going to give you anything. Right? You can do whatever you want. You can use your book and use the tables if you want, or you can use your calculator. I don't care. Can you work these really fast? Yes. Can you get the wrong answer really fast? My experience has been, oh yeah. I've seen a lot of wrong answers from people who have a calculator sitting there and they're done really fast. This is the danger of machines. What do computers do? Do programmers do the wrong thing and do the wrong thing every single time? Over and over and over and over. So you can have an error of a couple pennies and your financial statements are off by $100 million. Right? You know, there have been some really interesting frauds where people stole the rounding. They always had the thing round off at banking typically. They have the round off, down, right? Never round up, only round down when they're calculating interest for the customers, and they give themselves the rounding. Put in the bank account. Yeah, I think that was one of them. Yeah, it's pretty clever, huh? Millions of dollars in a big company, right? Yeah. So anyway, all right, rounding does matter in some situations, doesn't it? Okay, anyway, so you know how to use the tables too, right? No big deal. Feel free to use them. By the way, what we said, what if the interest rate was 12%? What would it have done in, how many years did I use? 12. What would it have done in 12? There's 3.89, right? What if you go to 15 years? 5.35. Look what happens with this growth. And it's not intuitive, is it? I don't know what it is without either calculating it or looking it up. I don't know about you guys. Okay? So you should have an idea about where you're at. But I'll tell you one thing. I think that a future value is always bigger than a present value. Unless the interest rate is 0. Do not give me a future value that's smaller than the present value, or I will make fun of you. What are you doing? I want to do business with you then, huh? You give me 120 now, and I get to use it, and I'll give you back 100 later, okay? That's what you're suggesting. So make sure your answers make sense when you do these, particularly when we get into annuities. You just give me ridiculous answers, okay? Don't do that. In fact, some of you on that problem I just gave you are going to give me ridiculous answers. You're going to go work at it, and you're not going to think it through, and then I'll make fun of you next time, okay? It'll be fun for me. So pay attention and think what happens. What physically happens? What do you do with the money? What's happening? Okay, got it? Okay, what'd you get for this one? What was the number you got in? What'd you guys get? Jump out there. Rounded, okay. 92,638? Something like that? 639. How many got that? Uh-oh, that's not a good sign. What'd you guys get?
79, 422.
It's a semi-annual.
79? Okay. Yeah, I did. 79 what?
422.
Do we have other ones? How many got 79, 422? How many got nothing? Oh, come on. I've got two numbers. What do you get?
I got 125,000, but I forgot to
Oh, you didn't do the semi-annual. So you got too much or too little? We're doing a present value. What would happen? If it's semi-annual, is there more or less interest? More or less interest if it's semi-annual versus annual. More or less interest. I'm calculating your present value. There's more periods.
Yes, you do.
Yeah. Really? So what'd you get if you got 100? You got 100 and what? About. Approximately. We better do this, guys. Okay, but you did. Everybody else thought they did it 6 months, right? Okay, so what happens if it's semi-annual? What are you going to do? Okay, the periods now is 20 periods, right? Everybody agree? It's 26-month periods. I think there's 26-month periods in 10 years. I'm a pretty sharp guy. I got that, right? Relax, right? You know that. What if it was quarters? 40? Right? Don't look at me like that, you guys. Don't make it hard. That's not hard. Okay, what happens to the interest rate if it's semi-annual? Interest rates are always stated annual basis, aren't they? Unless they tell you so much, 1% a month or something, right? I've never seen them stated otherwise. It's either monthly or annual, right? And they'll tell you if it's per month. It's obviously going to be a small number. Okay, so what is this? It's not 16%. What is it for 6 months? 8%. This would be just like you were doing a bond, wouldn't it? So what do I have? I have a future value, and you can set this up different ways. This is just how I happen to like to do it. The future value, how many periods from now? 20 is how much? 200,000. Everybody agree to that? That's that 200 there. Okay? What am I going to do with this puppy? I am going to make a present value out of it, times 0. So instead of being times 1 plus the interest rate for those 20 periods, right, for the number of periods, I'm going to put 1 over it. Does that make sense, everybody? Huh? I'm going to put 1 over it because I'm dividing now, right? You put the reciprocal in there, you're dividing. So what I'm doing is I'm taking 200 and dividing it by 1 over 1 plus the interest rate, and I'm doing it over and over and over and over. How many times am I going to do it? 20. And it's going to be at 8%. So this is 1 over 1.08 for 20 periods. As soon as I have that factor, I can multiply and get it. At least everybody got less than 200. That's good. Okay? What's the factor? Well, put in your calculator. What's 1 over 1.08 raised to 20? What do you get? Tell me if I screw up something here, you guys. I think I got that right, didn't I? Set up right? If I copy number wrong or something. What factor did you get? It's got to be less than 1, right? Because I'm taking interest out.
21455.
21455? Okay. Really? Huh. Let's look on the table. Do we have 8% 20 periods?
Table.
What's that?
That's from the table.
Oh, it's from the table.
Well, I did it on my calculator too.
Oh, you get the same. Okay, so on the table, which table would you look at?
Present value.
Yeah, okay. So, you just did 102 with me this summer. It's not fair, right? We just beat us to death a little bit, didn't we?
Yeah.
Yeah, it's really fresh. Okay, and you did in 101. Were you with me in 101?
Yeah.
Yeah. Okay, you did in the spring. Not fair, right? Just got it. Some of the rest of you, maybe it's been a little while. What do you need to do? Is it pissing you off that he just, oh, yeah, I got the table and I got the calculator both, and geez, that's annoying, right? Do you do some of this for a living or something?
No.
No, okay, you don't. Okay, that's right, you're working for a politician, so. Where are my signs for my yard? I'm sorry.
I do compliance, and I'll get you the sign.
Oh, I'll go down and get it. I won't tell you who supporting you. We're in a business school, so it's terrible. I'm kidding. It's all right. We can support whoever we want. Yeah, that's it. Okay, everybody can. It's America. Okay, anyway, so it's a good thing. So it is. What is it? They're only worth 20 cents on the dollar. What's 200,000 times 0.21455 then?
42.
What is this crap? What you guys do? Did we mess that up? Did you have this number?
I had it, but they started throwing.
But you didn't believe it. Oh, he lost his confidence. Ah, don't do that. You're in a meeting with the boss. Oh, it makes so much money. Yeah. Oh, I've had it. Yeah, sure. That's real valuable. You didn't tell us what it was. Let's prove that's true, you guys. Let's go the other direction. Take your present value and calculate the future value. What do you need to do? Take 42910 times 1.08 raised to the 20th and see if you get 200, huh? All right? You will, won't you? You did the math right. You will. It's true, isn't it? It's just the reverse of it. Just go in the other direction, right? If I knew my present value is 42, we'll put it here. If I knew this was 42910 times what? 1.08. Don't take the reciprocal, just multiply it to the 20th. I bet you anything that is going to give me $200,000. That did it? Yeah? What's this factor? 1.08 raised to the 20th. Look at the future value of a sum table. What do you get? It's the reciprocal. Put 1 over 0.21455 and you'll get that factor. It's somewhere around 5, isn't it?
4.66.
Okay? Yeah. Take a look at the table for a future value of a sum then. Right? Future value of a single sum, right? And what did I say, 8%? 20 periods? What's the number? 4.66096. It's a miracle. You could create one of these tables with the other one. I used to teach for the guy to do that. He was just mean. He'd give you the one you didn't need, and all you had to do was take 1 over it, get the other factor. And in those days, you didn't have calculators that would do it. And everybody missed it. How'd they make these tables, right? They're just using the formulas. It's just 1 over, right? Everybody got it? Annuity tables won't do that. The present value and future value of some will. Okay? Really nice. Little tricks with math, I guess. Okay. Well, let's try another one. That was dismal. This was really valuable. How many times do we have interest stated on an annual basis and have payments that are semi-annual or quarterly or monthly? All the time. All kinds of deals are this way. You buy a house, they don't really have you pay annual payments. They have you pay monthly payments. 5.25% interest. Let's do that. I got 5.25% interest on my house, okay? That's per year, of course, right? Not per month. 30 years mortgage. Tell me the number of periods and tell me the interest rate. If you were calculating the payment, if you wanted to get the payment on it. If you knew what the house, what you were paying for the house, right, you could figure out what the payment is. It's an annuity. No, it's a house mortgage. Monthly, every month. You make monthly payments. How many payments is that thing? 30 years times 12. 360 of them. What's the interest rate per month? 5.25 divided by 12. 12. It's not 360, yeah, it's 12 months, right? Okay, that's it. So the number of periods times 12, right? And the interest rate divided by 12. Big deal. Quarterly, 1/4 the interest rate, 4 times the payments. Right, guys? So I don't know what you guys did out there, but it was something different than I just did, huh? Right? How many of you had 42, 9, 10? One. Okay. You're going to fix it, right? Before I see you again, you're going to know this basic stuff. This is basic. Okay. Do that one. Did you do 3 yet? Did you get something that made sense? What kind of, well, let's just do it. What kind of interest rates we got?
7.2.
Just what?
7.2.
7.2%? Any other offers? 7. Okay. 7.2 is a little more accurate, maybe. 7.2. Anybody else? Or maybe it's 7.0, I don't know. How many have 7.2? 1, 2, and you have 7.5. You got, oh, you use the tables. Okay, you guys use the calculator? That would make sense. Okay, how many number of periods do we get down here?
10.
How many?
10.
10? Was this 10 periods? What'd you get?
Oh, down there.
Down, yeah, last one.
I got 4.
How many? 14. What'd you get?
14.2.
14.2? You used the tables, what'd you get? 14.2, I hear. What'd you get?
15,
Oh, I don't know. Okay, just because there's so many of them, but we'll see, right? Oh, that's number of periods this year. I'm sorry. 14.2. Again, it's 14.2 years. Okay, well, let's try these. How would you do it? Set it up exactly the same way. You can, by the way, you can put the present value on one side, the future value on the other. I don't care. You're just going to get a different kind of factor for your table if you do. Okay? All you do if you have a calculator is you plug in the present value, the future value, give it the number of periods, and ask it to calculate the interest rate. Down here, you put in your present value, your future value, the interest rate, and ask it to calculate the number of periods. Not kidding. Okay? Some of you need to look up the instructions for your calculators. Am I right? Okay? So this should be automatic, really quick. And we're going to do this all the time in our careers, you guys. Finance, accounting, both, the same thing anyway, right? You're going to be doing this stuff over and over and over and over and over. And you need to be just automatic. It's really fun when you go buy a car and the salesperson says, I need to go upstairs and figure out what the payment is, and you take your calculator and you show them what the payment is. Well, you don't need to go upstairs. I know what the payment would be. Well, how did you do that? I used to be able to do it by hand before I had a calculator faster than to go upstairs to get it. I was buying a Honda one time, and I was working at Ocean Mushroom Farms, and I was only like 2 miles from the car dealer. And they had 5 or 6 of the exact same model that I was going to buy. A little Honda Civic before they were known, right? A little tiny box, a little accordion thing. 1974 or something, you know, this little thing. Anyway, and so it was the cheapest car I could find at the time. And, so I was buying this little thing, and I went in, and the guy went upstairs to find out what they would be willing to sell me the car for. I went back to work and didn't say anything, but he already had my business card. He says, well, you left. And I says, I figured you'd call me when you figured out how much you wanted for the car. I got that car really, really cheap. Really cheap, right? So, no, and I also knew what I didn't care what the payment was going to be. That shook him up too. I says, I don't care what the payment is. I don't know how much I'm paying for it. I'm not going to finance with you guys anyway. Your interest rate's too high. Unless you want to tell me what your interest rate is, I'll tell you what the bank said. Let's see if that's the same. And of course, the bank beat them, right? So you have things lined up before you do a business deal, right? Any kind of business deal. You know exactly what you're willing to do, okay? Where you're at. So anyway, what is this? How would we get the interest rate? If I wrote down the present value here of 100,000 on one side, right? And then on the other side, I've got a future value How many periods from now is it? 10? Okay. 10 periods from now, it's 200,000. So I'm doubling my money. Okay. There is some factor in here, right? Which is going to be what? 1 plus the interest rate, which I don't know, raised to the 10th period, right? I'm going to solve for that interest rate right there. That's all I'm doing. Okay? What's the factor going to be? What is 1 plus the interest rate raised to the 10th? 2.0. The factor is 2.0. So what you could do, if you want to use the tables, is you could go here to the future value of the sum table, right? So let's go to the future value of the sum table. That's what you did for this one. Future value of the sum table. And it's table 6-1. Okay? How many periods did we say we had? 10? Let's go down to 10. And then let's go across until we find the 2. Where are we at? I always do this, don't I? We don't have 7% here. I guess you guys don't know. In this class, I do it all the time. It's somewhere between 6 and 7, isn't it? Or between 6 and 8, rather, is all we know, because we don't have a 7% for some reason on this table. But it is, isn't it? On a quiz or a test, I'd take that. Tell me somewhere between 6 and 8. What we could do is we could interpolate. Want me to show you how to interpolate? Is that what you did?
No, I just went between.
Use a calculator, you get it automatically, don't you? It's 7.2. You just use approximately 7. Okay, what you could do, here's interpolation, you guys. Let's do this. In case you ever
How
see
did you get that 2.0?
Oh, it's 7.2. That was your number. That's a 7.
I mean, that,
This one here?
no, the one in the middle there.
Oh, I took 100 and divided it into 200.
Okay.
Factor's got to be, right?
Yeah.
With me? That's all I did. I just divided it in. Oh, by the way, if you switch them, what would happen?
You go to the present value.
You'd have 0.5, right? If you had 200 over here and 100 over here, you'd have 0.5. Then you go to the present value sum table, and guess what? 0.5 is going to be right around 7%, isn't it? Okay, everybody good? So you can use the tables for this. Okay, but if we wanted to interpolate this thing, here's how you would do it. Did that answer your question?
Yes.
Okay. So this, you guys think this is 7.2% or so? Okay, let's see. For 6% and for 8%, usually you'll have at least on a table every percent. This one's weird. What was the factor for 6%? 10 periods. 1 point.
79085.
All right. What is it for 8%? You could do it this way. This is kind of cumbersome. The difference here is 2%, right? Everybody see that? What's the difference between those two? Subtract somebody. Okay. 2.15892 less 1.79085. Those of you who don't have a calculator, you might want to do it this way. Don't have a fancy calculator, though. Just calculate the interest rate. How much is that? 0.807? 0.36807? Is that what it is? Okay, that represents 2%. Then what you do is you take your 2.0 and subtract either one of them, right? And that's how far you're going to move, okay? So what's the difference percentage-wise between 2.0 and let's use the 2.15, it's maybe easier. Take 2.15 less 2.0, and what's that difference there? That's the portion of the 0.368, or the portion of the 2% that we've got, right? Make sense? So it's 0.15,
Yeah.
892. Okay, that's how much we're below. Everybody see that? So take 0.15892 and divide it by 0.36807. It's the percent of the distance we're going to move from the 6 to the 8. Got it? What percent is that? Actually, from the 8 to the 6. Get it back. I did this one right. 8 to the 6. Because the 2 is out here in the middle, right? What is that percentage?
2.31.
No, the other way around. 0.15892 divided by 0.36. Here's the spread, right? And this is the portion of the spread we've got. I should have pointed in the middle. So it's 0.48 or something?
Yeah, 0.4317.
0.4317, something like that?
Yeah.
Take that times 2%. And you got it. How far are we going to move? What is that, about 0.86?
0.86, 0.31.
0.86, something like that. Okay, so what I would have said is that much less than 8. So 8 less 0.86, 7.14. Would have been fairly close to the 7.2 you got with the calculator. And 2 of you got it with the calculator?
Yeah.
Good.
I did the table.
You did the table?
Yeah.
What did you get, 15?
No, that's number 4.
Oh, okay, I got you. Okay, so,
I got 7, because the table, I did the present table when it was .50835.
yeah, it's close.
Yeah.
Okay, yeah, you do have a 7% there. It was close. So, but you could still move it a little bit if you wanted. Right? Slightly more than 7 is good. Got it? Everybody good? Okay, so how would we do this one? It's exactly the same thing, you guys. I've got a present value at time 0 of how much? 100,000. I've got a future value over here, right? Get really good at this, please. Over here is 200, right? And that factor is still going to be what? 2.0. Everybody see it? Whoops, 2.0. That's the factor. That's the present value of a what? Or future value of a what? Sum, right? We're still on sums. So I go to the future value of sum table, right? I find that factor of 2, and what are you going to have? How many periods is it going to work out to be? About 15. Is that where it came up? Close to 15. If you used a calculator, you got 14.2 though. Is that right? Who got 14.2? You did? You did? Yeah. So, again, we could interpolate exactly the same way I did on the first one, and you'd get closer, right? So it should have been closer to 14 periods. Okay, but anyway, you got the idea how to do these, you guys? And if I give them to you on a quiz or a test, I'll make the numbers come out fairly close, right? So, you use the table, it'll be easy. Okay? Or you can use your calculator. All right, everybody good with present value, future value of a sum? No, but you will be, right? You get the idea. There are so many problems in there. You know what I would do on this chapter? I would work every single problem in this chapter until it was just automatic. I just boom, boom, boom. I've got it. The 30-second problems. I've given quizzes where I've given, I don't know, 20, 30 of these on a quiz. And you just work them and work them and work them and work them. If you know what you're doing, you just get them all right. Not frustrating at all. Really easy. Okay? Practice, practice, practice. Okay, let's switch to annuities. Okay? What makes something an annuity? First, there's annuity due, and then there's ordinary annuity. Okay, what makes something an annuity?
Making same payments for several periods.
Okay, so we're going to talk about an annuity due payment and an ordinary annuity payment.
Okay.
It's exactly the same payment. He's right. Exactly the same payment. Right? Every period. No period skipped. I don't know why we always say that, because if you skipped a period, wouldn't that one be 0? It's not the same. But anyway, we always say that. Okay? So there's the same payment every single period. No period skipped, right? And what else has to be assumed to stay the same? Or in the contract, it does stay the same. What is it? The interest rate. That's it. Exactly the same payment every period. Now, really, you guys, you could calculate the value of this, either the present value or future value of an annuity, by you doing each one as a sum, right? But what if it's a, 30-year annuity? Do you want to calculate the present value of 30 different cash flow streams and add them all together? Or would it be easier just to take an annuity factor and do one multiplication instead of 30? 30 multiplications and adding them all up versus just one multiplication. Which one would you take? And it's obvious, huh? Okay? All the annuity tables have done is they add up the factors from the sum tables. So if you take the factors from a present value of a sum table and you add them up, you will get the present value of an annuity table. Wow. If you take the factors from the future values of a sum table and add them up, you will get the future value of an annuity table. Got the idea? Okay, they just made it easy for you. That's all they're doing. Your calculator could care less. In your calculator, you tell it it's a payment, right? And you tell it either 1 or 0 for the payment at the beginning of the period. Beginning is 0, or that time 0, I think, and 1 is a year from now, right? Okay, they're at the end of the year. So you tell the calculator. Be sure to tell the calculator. It won't know what you're doing otherwise, right? Okay?
So again, learn how to use the calculator. So let's take a look at that real quick. Let's look at the present value of a sum table, okay? And let's use a column that is easy to compare, because we're going to do the present value of, say, an ordinary annuity, okay? So the present value of a sum, let's look at the 6% column there. And kind of fold your page over so you can see the 6% on the present value of an ordinary annuity. In fact, notice for year one, it's 0.939434. I can't say it. 0.94340. They just copied it, didn't they? Does everybody see what I'm doing? I'm on page 336 and at the same time on page 340. Okay? Everybody see that? It's the same factor, isn't it? Well, of course it is. It's one period, right? That's 6% discount. Look at the second one. It's 0.89000, right? On table 6.2 on page 336. Look what the factor is on the other table, the annuity. Add together 0.944 plus 0.89000, and what do you get? Very close to the same number, isn't it? Actually, it's a little more accurate on the ordinary annuity table. Oh, you can add them together. You know what? If you want, you can add up the first 10 periods. You can find out that the 10th one is equal to all those. The table, the formula, right? On the table, they just add them up for you. Isn't that nice of them? If you realize that's what you've got, and the same thing with the future value, right? If you realize that's what you got a million. Oh, big deal. Thank you for the table, right? I could have done it myself. Same guy that said it was so mean with me to get students one table or the other, not both, and make them do them. Right? I see no sense in that. But I want you to know what you're doing, right? Okay? So we want these payments. So you have to know when the cash changes hands. So how do you tell when you read one of these problems? It'll tell you. What did I do on the problem I just gave you before we started class? When are you making your investments into your retirement plan? Since you have to earn the money first. End of year. Now, really, it wouldn't be the end of year. It would be the end of every month, probably, right? Okay, but end of year. Okay, we make that assumption. Okay, so what kind of an annuity is that? Ordinarily, payments are at the end of a period. I don't know if that's why it's really named that, but that's an ordinary name. Okay, and it kind of makes sense. I remember it that way, right? It'll work. Ordinarily, payments on loans are at the end of the period, right? Investments typically pay off at the end of the period, not the beginning. Okay. Right? So that's ordinary. What's due mean? It's due. It's now. That one's easy, right? So payments at the beginning. So the retirement annuity is what kind of an annuity? When you retire and you buy that annuity, what do you buy? An annuity too. Okay? And you threw them right out there. You looked at this stuff before, obviously. Right? Okay, threw them right out. Everybody follow with that stuff? So when you're reading these, can I give you problems that have both in them? Well, of course. And there are problems in the book where they have both. Some are ordinary annuities, the payments are at the end. Some are annuity due, the payment is at the beginning. Could be cash out is an annuity due, and cash in is an ordinary annuity, right? Everybody got the idea? Again, it has to be the same interest rate, and it has to be the same payment every period, and then it's faster to use annuities. Okay? So, kind of nice. All right, guys. So I want you to calculate a couple of these. I want you to tell me what the payment would be. By the way, you don't need both the present value and the future value. You can have either one. Okay? So let's say my present value is $1 million. I want to draw money out for 20 periods. Okay? So 20 years, 20 whatever. And my interest rate is 8%. I am going to earn 8% for 20 years. I have $1 million right now that I'm going to invest, and I would like you to tell me what each of these annuity payments would be. What's the ordinary annuity payment and what's the annuity due payment? Can you do it? How do you set this thing up? Your calculator will do it for you. Excel will do it for you. How would you set this one? You making your head hurt yet? This is fun stuff we're doing. How would you set it up? You can either divide or multiply. The author showed you, right? I don't know why, but I prefer multiplying. My annuity payment, make an annuity due first, I guess. said, equals the present value times a factor for an annuity due. And it's the present value of an annuity due, because that's if it's a present value over here, I got to be present value here. Remember I said that when we first started? Keep them in order, right? Okay. Interest rate, what did I say, 8%? N equals 20. And here you might want to use the factors. You don't have to. Calculator will do it for you too. Just ask you to calculate the payment. So I've got it, and then we'll do so that's the annuity due payment, and then we'll do an ordinary annuity payment exactly the same way. Except the factor is going to be different, because it's not an annuity due factor, right? It's an ordinary annuity factor. There's more or less interest depending on which direction you're going, future value or present value, right? Because there's one more period or one less period depending on which one it is.
Is this an ordinary payment right there?
The first one's annuity due payment, the second one's ordinary annuity payment. Yeah. First we're doing this one. Annuity due payment, and then we'll do this one, okay? So it's an annuity due payment. So whatever this payment is, times whatever this factor is, equals what? $1 million. Oh, I could just go look up the factor and divide it into $1 million, and I'll get the annuity payment. Boom. That's what you're going to do for that problem that I gave you. Right? Where's your brain? Is this finance or accounting? When we do whack cap then, we're going to use this, guys. Next chapter, it's not even a chapter, it's a handout I gave you to read. We're going to use this. We value everything. The value stock system. You didn't ask me for that. What's the factor? Do we have an annuity due, present value annuity due table? You don't. Yeah, it's one or no, that's ordinary annuity. We have the annuity due also. One of the tables is missing. A future value of annuity due maybe is missing. I don't know why they don't put it in. I'll probably have to calculate some of them, so that's kind of fun. But we need to convert from one table to the other. It's not a big deal. So we have to do that too. Okay, but so anyway, what factor do I want of this present value of an annuity due table? How many periods was it? 20. What's the interest rate? 8. Can anybody find the factor? 10.60360. Is that what it is? What's worth $10.60? $1. It's annuity due, right? We're doing first. $1 received at the beginning of each period, right? So $1 received now is worth $1. Everybody good with that one? Notice the factor for one period is 1. That's because you're getting $1 now. See that? For any of the interest rates, $1 is $1. No kidding. Okay, so it's $1 plus $1 discounted for one period at 8%, plus $1 discounted, right, for two periods at 8%. So it's that cash flow stream of 20 payments, $1 at the beginning of each period, right? All 20 of those added up. Well, that's what they did with the factor. They added up 20 present value factors, right? For the 20 periods at 8%. So what's worth $10.60? 20 bucks is, right? Dollar received at the beginning of each period for 20 periods. How much interest would you earn? If you invest $10.60, you get back $20. $9.40, I guess, right? This is simple, okay? Get it intuitively, and this gets really easy, really easy. I actually convinced you this summer, didn't I? Worked, didn't it? Yeah. I could just do that with you guys. Nobody did it for me. That's why I make such a big deal out of this. I was doing it. I was really good at doing it. I didn't know what I was doing. It was really wonderful. And then I went to work. Figured, oh, this stuff's cool. We can make money with this. Nobody ever told me that. And we started making money with it. Anyway, I know you guys are all greedy people, so. All right, take 10.6036 and divide it into a million. What do you get? 94,207. 307. Okay. What does that mean? What's 94,307? How much you would what? If I invest $1 million,
I can take out what? Is that right?
That's the payment, right?
That's really crummy, isn't it? No, it's not crummy. Yeah, that's the payment. It's not crummy. How many payments am I going to get? 20. How much is that? What's 94,307 times 20 payments?
1,886,151.
How much did you invest? $1 million. How much did you get out? 1,886,000. You made $886,000. Got it. So we just calculated. I'll ask you things like, how much interest did they earn? Right? Easy, isn't it? Okay, calculate and tell me. All right, do the same thing. First, tell me on an ordinary annuity payment, is this going to be a bigger or a smaller payment?
Bigger.
Why bigger? Because you are leaving the money in what? One more period. It's got to be bigger, huh? You're going to earn a period, one more period's interest on every single one of these, right? Every single one of these payments.
On the due.
On the due, you're getting your money now. You've got to be really careful with this. Yeah.
Not bad.
Yeah, and if we were doing future values, the reverse would be true. So it turns your brain inside out, right? Okay, that's why it bugs you, okay? But yeah, so try that one. Do that one, you guys. If this is 94,307, let's try the other one. You would expect it to be what, a bigger or smaller number? Bigger because you're leaving your money in a little longer, okay? So let's see how much bigger. Let's do that one. So what's it going to look like when we do it over here? How would you set it up? Do an ordinary annuity payment, right? And by the way, you can divide the way the author does if you want to. I don't care, as long as you get the right answer. For some reason, I always like to multiply. I don't know why. Right? This time it's still a present value. By the way, if I knew the future value, what would I do, everybody? Put the future value here instead of the present value and do what? Pick up a future value factor instead of a present value factor, don't you suppose? Let's go to a different table. Right? This is going to be a present value of a ordinary annuity. Get on the right table. Ordinary annuity factor. Okay? Interest rate, 8% was it? Number of periods, 20. Right, guys? Okay, what kind of a factor do you get? So this time, let's go to the present value of an ordinary annuity table. Table 6-4. 20 periods, 12% was it? 8%. What factor do you get? Let me show you a little trick here. Move up one period, and what's the factor?
What's the other one?
What the other one was? Yeah. You only need one of these tables, don't you? Yeah, it's real close. It's round. Yeah? Wow. Oh, man. Oh, man. So you can convert these tables one into the other. Okay? Gives you a one. Okay? You'll be do some off there like that anyway with the future value ones. Same thing works there. Okay? All you have to do to add one period to this is take 9.60360 times 1.08, and you'll have 9.81, right? That's what's going on. Okay, just the first. Okay, anyway, let's see. So our factor is 9.81815. $9.818. Is that what it was? 15. Okay. What was my present value? It's still $1 million, right? So what would the payment be if I take them at the end of the period? 101,853 or so.
Yeah.
It'd make a difference, wouldn't it? Oh, yeah. You got $1 million invested, right? Makes a big difference. Okay. I chose that wrong, you guys. It's 10 because the 9.60360, I have to add 1 to it because the first payment's a 1. So you just add 1. 9.60360, so you go 1 year down, and then you add a 1 for the first year, right? You get to 10.60. The reverse would be true too. You go to the other table, right? You go up a year, right, and then subtract 1 from it. Yeah. Okay? Convert into each other. So these easy? Kinda. Okay. This one was. All right. So let's do this. Any questions about anything? I know it's perfectly unclear. Okay. You gotta work them, you gotta work them, you gotta work them. But I think if you set them up like this, you'll have it made up. I like personal preference, just personal preference. I like to set it up so I've got present value on one side times a factor is the future value, right? Or the future value times a factor is the present value, okay, for the sums. Whether I'm calculating the interest rate or the number of periods or the present value or the future value, it doesn't matter. If you want to, you can always use a present value table, right? Set it up like this, I guess, huh? If you want to, you can always use a future value table. Set it up like that, right? It'll work fine, okay? And just solve for what's missing. Always solve for what's missing, okay? So if you know any three, present value, future value, interest rate, number of periods, you can calculate the other one. Make sure you can. If two are missing, you have more of a problem. By the way, when we do whack tap in, all of them are missing. We're trying to figure them out, okay? Now we get into something real, okay? And real challenge, therefore real valuable, I guess. All right. And then on this one, what I like to do for the annuities is I like to set it up. You can do it any way you want, but I like the payment, regardless of whether it's ordinary or due, but make sure you know which one you're working with because that's going to determine which factor you want. That makes sense? If I'm due here, I've got to be due, right, on the factor. If I'm ordinary here, I've got to be ordinary here. Makes sense? I can either put the present value over on this side or I can put a future value over there. I don't care. And in a problem, they'll give me one or the other, right? But if I know the future value, what kind of a factor do you want? A future value factor. Makes sense? If I know the present value, what do I want? A present value factor, of course. Okay? If I have an ordinary annuity, what kind of a factor do I want? If it's an ordinary annuity payment, an ordinary factor. If it's a due payment, a due factor. Why do I say that stuff to you guys? Guess what students do to me all the time, to themselves? Mix up the tables, grab the wrong one, right? And then do everything right, have it all laid out right, and grab the wrong table. So don't do it. Think all the way through. These are not going to take very much time to do. They're going to take thinking to do. Okay? Let's do something else. If you guys are all okay. Probably not really, but sort of okay. We got a few more minutes, don't we?
Let's find a crumple. It's fun.
Okay. Let's do problem 6-1. Just 6-1. Start there. Page 327. On A. Want to read A for us? You don't have it. Yeah. Okay, so what are we going to be looking for? So we're on 6-1, page, what was it, 327? Okay. What are we going to be looking for here, you guys? Tell me the things, when you take charge of the problems. Don't let them take charge of you. You take charge of the problems. What are we looking for? What do you want to know? We're doing present value problems, you guys. What do we want to know? What kind of things might we want to know? What might they ask you? They're going to give you most of the information, and you're going to solve for one thing every time. Every problem's like that. In these problems, the CPA exam problems, it's always like that. Okay, it's really nice. What are the things that they could either give you or ask you for? What would they be? If just off the top of your head, what things do you want? What do you want? What? Present value. Okay, they could ask me for a present value at time 0. That's one thing. What else?
Future value.
Future value. Some number of periods. What else? Interest rate. What else? That's an I. You know what was really funny? I wrote something kind of like this in the principal's class today. I started doing this with them. And they said, what is C with an accent on top of it? I thought it was fun. I must not have said interest enough times. That and little R. I told you this one, didn't I? I write depreciation over and over and over, you know. But constantly I have this run over a little bit like that. So I have people give me department expense all the time in principles. I don't know what department expense is, but I get DEPT expense all the time. Yeah, anyway. That's fun. I don't mark it wrong. Oh, well, at least they look at their notes, right? Department expense, okay. Anyway, and then what's the last piece, of course?
Periods.
Yeah, number of periods. Okay, so when you're reading these things, you know, they may give you those. Now, there's one other possibility. What is it? There could have a what? We just added annuity payments, right? Okay, so we could have an annuity payment, and so there might be that. So they could give us either present value or future value, right, and then put in an annuity payment. They don't have to give us both. They give us both, fine. We don't care. All right? Obviously, if there's a present value, there's also a future value. Right, guys? You can calculate the annuity payment with either one. And if it's an annuity payment, it's one of the two kinds. What are they? Ordinary, or it's a due, and it cannot be both. So that's what you're asking yourself all the time, right? When you look at these things, what did they give me? Okay? All right? So read it to us. What does it say?
January 1st, 2014, Fishbone Corporation sold a building that cost $250,000 to have. It had accumulated depreciation of $100,000 for James the building.
Okay, cost is $250. Accumulated depreciation is what? Book value, therefore, is $150. Everybody agree to that? Okay, good. What else you got? January 1st? Good. What else you got?
Fishbone received as consideration a $240,000 non-interest bearing note due January 1st, 2017.
Note receivable. Right? Note receivable. $240,000. Non-interest bearing. Let me ask you this. They're doing business with each other. Did they really not charge them interest? How many of you would lend somebody $240,000 with no interest? You would not. It includes the interest. That's it. We're going to impute interest to it. We're going to compute the imputed interest. Got it? Okay, imputed. What's implied in it? Okay. All right. So what else do you know?
There was no established exchange price for the building. No
We don't know what it's worth. That's just what we're going to retire when we sell it, right? Okay, no established market price. Okay. So what do you got?
The prevailing rate of interest for January 1st, 2014 was 9%.
9% on that date. Did they get anything besides the note receivable? Did they get any cash? If there was a cash down payment, let's say there was a $10,000 cash down payment, what's that worth at any discount rate? $10,000 right now. 10. So I'd add 10, right, if they made a down payment. They didn't, did they? So what they got is a note receivable of $240,000. I bet that's some sort of a future value. What do you guys think? It's exactly what you do. I'm getting that in the future. Okay? It's a lump sum. They're not making payments, are they? I'm asking. I haven't read it. So just 240, 9%. When are they going to pay it? Let's say.
January 1st, 2017.
How many years out is that? This is 14. It's due in 2017. January 1st, 2017. It's not December 31st. January 1st.
Yeah.
You got to count careful. If it's December 31st, it'd be 4 years, right, guys? This is 3 years, isn't it? Right? January 1st. So that matters, right? If they said December 31st, now I got 4 years. I've only got 3. Does everybody agree with that? 15, 16, 17. Okay? In is 3. Oh my gosh. I bet they want to know the present value. What does it say?
And what amounts to the gain from the sale of the building here?
Well, in order to record the gain, what do I have to do? Debit note receivable. For how much? 240,000. Credit what? This is equipment, was it, or building? Equipment. Building. Boy, that's a cheap building. Okay, I got a building that was 250,000. I retired it, right? Credit. What else am I going to do? Get rid of accumulated depreciation, aren't I? Everybody agree with that? So now everybody wants to have a what? Gain, I guess? You like that? I don't, because I don't think it's worth 240,000. The note's not. I think I have a discount on the note. What's the discount on the note receivable? In other words, how much is interest?
So I'm gonna calculate the present value of that note, and that's what the note is really worth. Right?
So there's gonna be a discount on the note, which is gonna be the future interest. It's gonna be interest revenue for me.
Oh,
Okay, so we use this stuff for all kinds of things, you guys. So go ahead and calculate that, and then we'll have a gain or a loss in our journal for you there. Go ahead and calculate the value of it. Do that real quick. What is the present value of that thing? Keep it there a second. What's the present value of that? How would you do it? How would you set that up? My future value, 3 periods from now, is 240,000.
So,
The present value now is how much? Take it times what? 1 over 1 plus the interest rate raised to the number of periods, right? Which is 1 over 1.09 raised to the third. Right, guys? It is. Go to the table, present value of the sum, 3 periods, 9%, and you will get the factor. That's what $1 received 3 periods from now, discounted at 9% is worth. How much is that worth, by the way? If you look at the table. 77218. If I invest 77 cents at 9% interest, compound for 3 periods, it will grow to how much? $1. That's why $1, 3 periods from now, discounted at 9%, is only worth 77 cents. How much interest would I earn? 23 cents. Got it? Everybody sees this, just intuitively grasp it. All right? Big deal. Okay, so I'm getting 240,000, but those dollars are only worth 77 cents each. The rest is going to be interest. Got it? Getting there? So, and by the way, you guys, do you know this really well, this whole thing about imputing interest? Not really. But is it just common sense that there would be interest in the deal? Nobody, when furniture stores do this all the time. No interest for a year. Sure, there's no interest for a year. Of course there's interest. What do? They charge you more for the furniture. Try it sometimes. Go in, if you want that piece of furniture from that furniture store and they have no interest for a year. Offer them 10% less and see what they say. Yes. Or they might say, no, I'll only give you 5. Why would that be? Depends what their interest rate is that they're paying, right? If they make just as much money either way, what do they care, right? If you pay less or if the interest is included. Depends what interest rate they pay though, not what interest rate you should have to pay. They're not charging you that way anyway.
so does that mean they're pulling people?
You don't have to be fooled if you don't want to.
If they say
You
like,
could have knowledge, not be fooled. They're just doing business.
no, but they're saying no interest and
I think they're fooling them, but I think it's quite ethical. If people want to be gullible, they can be gullible. I think it's okay for people to gamble at the horse track too, as long as they know they're going to lose their money. And it's entertainment to them. It's okay to gamble at the casino, as long as they know they're going there for entertainment, they're going to lose their money. Are they stealing their money? Of course not. People are voluntarily giving it to them, right? Now, if somebody's addicted to gambling, that's a whole different story, perhaps, right? Maybe we should protect those people, I guess. Right? But,
the reason I ask is because in this case most of the public don't know there is actual interest in
I know.
They believe it's
They'd like to
zero
believe that they
interest.
got a really good deal on the furniture and paid no interest.
Yeah, so
But you know what, if they don't have the money right now, and they want the piece of furniture, so the interest is included in the purchase price. They get the piece of furniture. These are tough ethical issues, aren't they? They really are.
yeah.
Right? What's ripping people off? Is advertising unethical? You convince people to buy something they don't really want for a price higher than they're willing to pay. But if you have a really good ad, you can pull it off. Ethical? I ignore advertising myself, or try to, totally. I try not to look at ads. Still there's subconscious, of course. Right? Walmart advertises a lot. I don't go to their store. They can keep running advertising. Bud Light advertises a lot, too. I don't buy Bud Light. Tastes awful. I'm not going to buy that. I know some of you guys drink that, but that's because you like water better than beer. What? Oh, thank you. Good. Okay, well, let's before my wife kills me. What was the answer, anyway? Let's calculate it. 240 times 0.77218. What do we get?
185,
185, 3 what? Something like that. Okay, now what would we do with that? We'll do it real quick. Then my wife will kill me. Okay, here we go. 185, 323, where does that go? Look, you guys, the note's not 240. You can either reduce the note down, right? Or you can put in a discount. Either way is acceptable. What's the discount on the note? How much is interest there? Take 240 less 185, 323. What's the discount? Almost 40 and 15, almost 55, 54,000 something.
54, 6, 7.
That's it. What's that going to be when they pay you? Let's do 1 year later they pay us. What do you want to do, guys? How much cash are they going to give me? It was 240,000 note, interest free. How much cash are they going to give me? They owe me 240,000. There is no interest. What's they going to pay me? 240. Okay, they think they're paying no interest, but actually they probably know they are. Right? Yeah, that's the deal. They know they are. Doesn't matter. They know there's interest in it. Okay. And then what else is going to happen? Oh, by the way, there was a gain or a loss. I didn't do that. They said it was a gain. I guess it's a gain. How much is the gain on sale? 340. Right? Is that a gain? It's a loss. It must have been said gain or loss. It's a big loss. Okay, because what you got for it is 185, 323, and its carrying value. No, you got 183, 323. It is to a gain. It's a gain. Don't rush. Well, what's the carrying value of the thing? 250 less 100 is 150. What did you get? 240, right? Less the discount. So 185, 323 away from the 150. I think it's a gain of 35, 323. Don't you guys? Gain on sale. Okay, it was a gain. Is that right? That journal entry balance? 350 here and 350 here. Okay? All right, there's your gain. So now when they pay us, we'll debit cash and we'll credit note receivable, won't we? But be careful. We still have that discount to get rid of, don't we? We got to get rid of this discount if we get rid of the note. So discount on notes receivable? We'll do another problem like this one. How much? It's like 54,677. What did we say that discount was? Interest. A year went by, and I earned what? Interest. 54,677. And I'm going to call it interest what? Seeing as I earned it. Revenue. Got it. See you guys.